Hello, good morning everyone. Today we will start the second part of class 9 chapter structure of atom. In the first part we had seen up to the properties of electron, proton and neutron, the discovery of electron, proton and neutron. Now in the second part we are going to see about the structure of atom. About the structure of atom, so many models has been given. For example, Thompson model of an atom was given, Rutherford model of an atom was given, Niels Bohr model of an atom was given. So we will see by each of them one by one. First we will see about the Thompson's model of an atom. In the Thompson's model of atom, we will see that in 1903, J.J. Thompson gave his theory, gave his knowledge about the model of atom. As I have already told you all that neutron was discovered in 1932. So in 1903, neutron was not discovered. Only electron and protons were known. So what model J.J. Thompson had given? He had given excluding neutron. What he had told? He told that an atom is like that of a watermelon, where the positive part is the red part of the watermelon and the negative part, the electrons, are the seeds of the watermelon, that is dispersed here and there. That means not in a uniform way. We can see that the seeds can be found anywhere. So in the same way he had told that an atom can be found to be like that of a watermelon, where the red part shows the positive part of the atom and the seeds represent the electrons. He had also told that we can express or we can tell that an atom is like that of a Christmas pudding, where the different dry fruits, they represent the electrons and the whole of the cake or that pudding represents the proton part. Next we have about the alpha particle scattering experiment given by Rutherford. What he did, he took alpha particles. What are alpha particles? Helium-2 plus atoms, or we can say helium-2 plus ions, not atoms, ions. The helium-2 plus ions, we call them as the alpha particles. And what Rutherford had done, he had taken a thin foil of gold. Thin foil of gold he had taken, and then through that thin foil of gold he had passed so many alpha particles. And when he had passed so many alpha particles, as you can see the diagram in your book also, it is given, and here also a little bit I am explaining. Suppose these are the atoms of the gold foil. In this what we have, as it was thought that time that here protons are there and electrons are in this way. And then he allowed so many alpha particles to pass through them. Then it was observed that most of the alpha particles passed straight, undeviated. Most of the alpha particles he observed to pass undeviated. a few of the alpha particles. What he observed? That a few of the alpha particles bend with large angles, and out of 1200, one of them turned towards the same side from which direction it was coming. So after observing this thing, Rutherford gave his conclusion. What conclusion he gave? He told that most of the rays passed undeviated straight. That means most of the space in an atom is empty. He told that second observation he had seen that a few of them bend with large angle. So he told that a few of them were able to bend with large angle because these alpha particles, they are positively charged particles, and then the something in the atom is also positively charged, that is repelling it, and that's why it is bending with large angle, it is going away. Third observation that he had seen was that a few, that means 1 out of 1200 rays, that alpha particle bent with small angle towards the same side from which side the alpha particle was coming. So he told that this is because something heavy, something denser, something of large mass is there at the center, which is repelling it or which is bouncing it back towards the same side. Thus, in this way, he told that in the center there is heavy part, heavy thing, and then it is called as the nucleus. What did more he tell about the nucleus? He told that this nucleus is very, very small in size. We can understand in this way about the size of the nucleus. Suppose we take the Eden Garden of our India, of Kolkata, as the atom, and then in that Eden Garden, if we put a P in the center, then that P represents the nucleus of an atom. So now you can understand how small the nucleus is. It is very, very small. Next we had about the nucleus. So nucleus, I told you only about the nucleus, about the size of the nucleus, how small it is, and then the nucleus is positively charged as a whole. Because in the nucleus there are protons and neutrons, and protons are positively charged and neutrons have got no charge. So overall the charge in the nucleus is positive. And in the nucleus there are protons and neutrons, and together we call them as the nucleons. The volume of the nucleus of an atom is very, very small as compared to the volume of the atom as a whole. And in the nucleus, the protons remain fixed. They do not move, they do not rotate, they do not go around in the orbit as the electrons do. That means the electrons keep on moving around the nucleus in their orbits, in their shells, in their energy levels, but these protons, they remain fixed in the nucleus. Next we have Rutherford's model of the atom. What were the points, what were the postulates given by Rutherford? After performing his alpha particle scattering experiment, Rutherford gave some postulates, some points, some theory, and that we call them as the points of the Rutherford's model of the atom. In the Rutherford's model of an atom, Rutherford told us, after observing what he has observed in the experiment, he told us that the atom, most part of the atom is empty. Second part, he told that the size of the nucleus is very, very small. Third point, he told that the nucleus is dense, heavy, positively charged. Third point, we can say that the electrostatic attraction between the positively charged nucleus and the negatively charged electrons hold the atoms together. He also told, next point we can say, he also told that the nucleus is as a whole positively charged and atom as a whole is neutral, because as many protons are there, so many electrons are there. So overall charge of the atom is cancelled and hence it is neutral. Next we have drawbacks of the Rutherford's model of an atom. What is the drawback? No, demerit we can say. Demerit of the Rutherford's model of an atom. In the Rutherford's model of atom, he had told that the electrons remain outside, the electrons keep on moving around in the orbit, protons remain inside in the nucleus. Then according to electromagnetic theory of physics, if a particle keeps on rotating or moving in a circular path, then after some time what happens? Its energy must decrease, because when it is rotating in a circular path, it will radiate out some energy. And so when these electrons keep on moving in the circular path, in the orbits, in the energy level, in the cells, energy shells, then they must also be giving out energy. They must also radiate energy. A time must come when their energy would be over and they would collapse and mix with the center, with the nucleus. So the contemporary scientists questioned Rutherford about the stability of the atom. He told that if electrons keep on moving around in the circular path, in the orbits, then it will also radiate out energy according to this electromagnetic theory of physics. Then a time must come when their whole energy will be over and they will collapse and meet with the nucleus. That means they will stop rotating, they will not have energy, they will not have energy which will keep them rotating in that circular path, in the orbits, in the energy levels. Then Rutherford, he was unable to explain that. He was unable to answer the questions of the contemporary scientists. So this is considered as one of the drawbacks of Rutherford's model of the atom, where he could not explain the stability of the atom. Then it so happened that another scientist whose name was Niels Bohr, he came forward in 1913. See, this Rutherford's model of an atom was given by Rutherford. He could not explain about the stability of the atoms. Then Niels Bohr came forward in 1913 and he told that yes, I can give the explanation for the stability of the atom. What he told? He told that yes, it is correct according to the electromagnetic theory of physics that when an atom or when a particle or when a substance is moving in a circular path, then it will radiate out energy and a time will come when its energy will be over and it must collapse. it must not be able to move any more further. But here in the case of atom, it is an exceptional case, and these atoms, they also rotate in their energy shells, in their energy levels, in the orbits around the nucleus. They also keep on moving, but they do not radiate out energy. They do not give out energy. And when they are not radiating energy, when they are not giving energy, where is the chance for the end of the energy? How is that they will come to stop, or how is the chance that they will collapse? And therefore, since it is not giving out energy, it is not radiating energy, it is not collapsing, and hence the stability of the atom is maintained. And he gave some points, two, 3 points he told about this. What he told, that the electrons to move around the nucleus only in certain orbits. That is, suppose this is the nucleus. In the nucleus there are protons and neutrons, and this is the orbit. In this orbit, suppose one electron is revolving, it is going around the nucleus, then each shell has got certain energy level. That means the electrons moving in each shell has got certain amount of energy. And with that certain energy, electrons rotate in each shell. So what he had told, that electrons could revolve around the nucleus only certain orbits, and each orbit, the electrons revolving in each orbit has got certain energy. And he also told that this orbit that is here, it is having some radius. What is the radius? That means the nucleus, the center of this nucleus, and this is the orbit. The linear distance between this center and the orbit will be known as the radius of the atom, or it will be considered as the distance between the center and that shell. If we have another cell, if we have one more shell, if we have one more orbit, then from here center up to this distance, this will be the radius for this shell, for this energy level. And he told that each orbits have got different radius. This orbit has got, this one has the radius. For this orbit, the radius has changed. So each orbit has got different radius. Next he told that when an electron revolving in a particular orbit or energy level around the nucleus, the electron does not radiate energy. That I already told you. Even though it has accelerated motion around the nucleus. Although it is having accelerated motion around the nucleus, but it is an exceptional case, and this electron does not radiate out energy. The electrons do not radiate out energy, that I have already told you all. Next point we have, next topic in our syllabus is Bohr's model of an atom. So what were the points given by Niels Bohr, saying what, when Niels Bohr he told us, when he came forward for the explanation of the stability of the atom, in that stability of the atom, he told those 2 points that I told you. Now we will see the Niels Bohr's model of an atom. Whatever things he had told, actually these points what he had told was already told by the earlier scientists, but he added a few of the points. Let us see one by one. He told that an atom, in point number 1 we can say that he told that an atom consists of electron, proton and neutron. That means in an atom there are electrons, protons and neutrons. Next he told that the proton and the neutrons are located in the nucleus. That the electrons and protons, they are located in the nucleus, and the nucleus is positively charged as a whole. Next point, he told that the electrons keep on revolving around the nucleus in certain energy levels or shells that we can call them as KLM, N or 1, 2, 3. In that way we can name it. First one we will name K or 1. If we are naming 1, then 1, 2, 3 like that. K, L, then M, N like that. In that way he told us. Next he told that there is a limit to the number of electrons which each energy level can hold. That means in this shell, how many electrons can accommodate, how many electrons can remain, that varies from shell to shell. That means each shell will have got certain limitations, some limit they have got, that how many electrons they can hold. Next point, he told that each energy level is associated with fixed amount of energy. But he told that each energy level is associated with certain amount of energy. And the sixth point, he is told that there is no change in the energy of the electron as long as they keep on revolving in the same energy level and the atoms remain stable. This is what he had given here in the about the stability of the atom. That point also he added. So what we are seeing, more or less two new things he had added about the name of these shells, K11. Then he told about the stability. And if we take another point, then we can say he also told about the energy level, no? That in each orbit or the shell there are certain amount of energy, and the electrons they keep on revolving around the shell, then they have got this fixed energy with certain energy, and the energy of the changes as the shell changes. And he also told that these electrons do not radiate out energy. So all these 6 points come under the points of Rutherford's model of an atom. Niels Bohr model of an atom. In this Niels Bohr's model of atom, he told these 6 points. Next topic is our atomic number. Next topic is our atomic number. What is atomic number? Atomic number. In a neutral atom, if we talk about the neutral atom, in a neutral atom we can say atomic number means number of electrons or number of protons. But it so happens that if I say usually like this, that atomic number means number of electrons, it may be wrong. We have to say in an atomic number means number of electrons in a neutral atom, because atoms may lose or gain electrons also. So it is better, the best way to define atomic number is atomic number means number of protons, because proton can neither can be gained nor can be donated. So we define in this way, atomic number means number of protons. And atomic number we denote it by capital Z. And next we have mass number. What is mass number? Mass number we denote it by capital A, and mass number means number of protons plus number of neutrons. That means in short we can say number of nucleons. When we are writing any atom and we want to write their atomic number and mass number, then we write in this way. Suppose we have helium, atomic number 2, mass number 4. For example, we have sodium, atomic number 11, mass number 23. See, some different books, different places you may observe like this also it is written. Both they write same side. here also. But you have to remember that mass number should be on the top and atomic number at least should be at the bottom. Whether you write in this way, or you write in this way, or you write in this way. In your book, you can see how they have given. They have given in this way. How you will remember which one to write top, which one to write bottom? See, when you are writing A to Z, you write A, B, C, D. A, B, C, D, you write Z, you write at last. So A must be written here. See, A is what? Mass number. And Z is bottom, so Z you write at bottom. Or you can understand in this way, or you can remember in this way, that mass means number of proton and neutron, so it will be heavier. So heavier thing you keep on your head, and lighter thing you keep at the bottom. So heavy thing you write on the top, and the smaller one, the less one you write at the bottom. Next topic, a relation between mass number and atomic number. The relation between mass number and atomic number. See here. Just now I told you mass number is equal to. Acha, one thing more. Mass number is also known as atomic mass. See here, atomic number, mass number is also called atomic mass. So atomic mass number is equal to atomic mass number, definition I told you, is equal to number of protons plus number of neutrons. And we know that the number of protons is known as the atomic number. So instead of number of protons, can I write atomic number? Let me write atomic number. And this, we denote atomic number with Z and number of neutrons with N. So this is our relation between mass number and atomic number. That mass number is equal to atomic number plus number of neutrons. So you may be asked numericals or based on this, that you are given atomic number, you are given mass number, find the number of neutrons. Or you are given number of neutrons and you are given mass number, find the atomic number. Out of these three, only two may be given to you and the third one may be asked to find out. Now next part we will see another day.